weak nuclear force, or weak interaction, is responsible for radioactivity. For example, beta radiation, ejecting electrons and neutrinos. It's the force that turns a neutron into a proton. Unlike quantum electrodynamics and quantum thermodynamics, there is no separate matter field that creates a particle with a weak force charge, sometimes called weak isospin or weak hypercharge. Instead, all fermions already have this charge, including electrons, quarks, and neutrinos. Like accelerating electrons and quarks create vibrating ripples in their respective force fields, called photons and gluons, respectively. Accelerating electrons, quarks, and neutrinos can create vibrating ripples in the weak hyperfield, called W+, W-, and Z particles. They are spin 1 particles, making them bosons. They are the force particles for the weak interaction. And when interacting electrons and gluons disturb their respective force fields, creating virtual photons and gluons, interacting particles with the weak hypercharge disturb the weak hypercharge field, creating virtual W and Z bosons. We call it the weak force because its coupling constant is 3.3 million times smaller than the strong force coupling constant. And unlike massless photons and gluons, these particles are massive, around 50 times more massive than an up quark and 160,000 times more massive than an electron. This makes the range of the weak force around 0.1% of the diameter of a proton. The weak interaction can change one flavor of quark into another. The idea that a field can cause a particle to decay was a new one. We'll use beta decay from our radium to polonium energy experiment to help illustrate how this works. The process consists of 2 phases. The first phase is similar to the way an electron emits a photon when it drops to a lower energy state in an atom. Here, a down quark drops to a lower energy up quark and emits a W boson. However, the mass of the weak field quantum is so large that there is not enough energy in a down quark quantum leap to an up quark to create a fully independent W boson. Instead, what is created is a virtual W boson. However, in the second phase, because there is enough energy in the virtual boson to create an electron and a neutrino, it decays into these particles. This is possible because both the electron and the neutrino carry the weak hypercharge. This is how our radium turned into polonium in our segment on the atom.